We're going to kick off this afternoon or this morning's presentations and invite WISER Systems to the stage.
All right. Hello, everyone. My name is Elliot Haig. I'm from WISER Systems. And what you're looking at right now, and some of you might be ahead of me on this, is WISER Systems. So this is actually a really cool data set. This is me frantically pacing before this presentation and walking around and neurotically checking my antennas. So I want to invite you guys to kind of do some of the same. There is a tag on the very tip end of each table. So feel free to grab that, check it out, look at it, pass it around the judges table, pass it back into the audience. It's not like I'm going to lose the thing, so feel free to play with that a little bit. And in the meantime, I want to take you on just a little journey into the land of make-believe. So let's say that you work at a large automotive manufacturing company. And it's a big factory, it's a big plant. You make about 1,300 cars per day. And you need things like calibration tools to make sure, yeah, if you throw that at me, I might catch it. Okay. Gotcha. So, so you make about 1,300 cars a day. You have calibration tools to make sure that important things happen, like the bolts go on the right way so the wheels don't fall off, things like that. Maybe it's as simple as a pallet of parts that you need to be able to continue the process. And if you don't have those things, the process shuts down. Now, maybe you don't have the pallet of parts. Maybe that makes an hour delay. It takes you an hour to find this. It's not too bad. You're done for an hour. You're down for an hour, rather, and then everyone gets back to work and everyone's happy. But really what happens in that hour of downtime in some of these big manufacturing plants? So let's say it's, again, a very large plant, open 24 hours a day. That's still about 54 cars an hour. So if each of those cars sell for just $12,000 a piece, that's $648,000 lost in that 1 hour of downtime. So if any NASA types want to check my math on that, I encourage you not to, please. And this is what we do. We tell you where your stuff is. And if there's one thing that I've learned from my time working at WISER is that people will lose anything. It's actually kind of incredible. I'm talking pallets, I'm talking parts, other people, buses. People lose buses. If someone from NASA came up to me and said, well, there was a sketchy 2 to 3 month period there where we weren't exactly sure where the space shuttle was, I would say, yeah, that sounds about right, and you're in good company. But maybe don't admit that. Well, the CFO's here today. So I hope you guys have had a good look at this. I'm going to switch over to some slides now, Robin. And I'll put this up again later so you guys can play with it if you want. But just for some increased context, WISER is a mesh system. So I set up this quick little mesh this morning in the 4 corners of the room. I know you can see the antennas there. So the antennas create a grid, and then the tags go on the assets. So that could be a person, that could be a box of goods here, it could be the forklift. And just some idea of scale, each grid square can be anywhere from 2,500 to 40,000 square feet. And then these are generally powered for a permanent installation over power over Ethernet, but they can also be battery powered or solar powered if the installation's outside. So what makes WISER different, unique? So this is an ultra-wideband technology, so this is the latest and greatest in real-time location tech. The reason that's better is that it's basically my job to put this demo up in industrial and difficult situations in places where RTLS has not worked before, or real-time tracking has not worked before, because they want this, and there have been technologies in the past that they've tried. And generally, we'll go in and we'll look up, and there'll be, maybe an active RFID system in the rafters that is bought and paid for. Many times they cost 7 figures, and it doesn't work. And obviously, it doesn't work, or we wouldn't be in there in the first place testing out something new. So what makes us work in metallic and complex environments? There's 2 things that make it difficult. A lot of these technologies require reflections to make sense of where the ping is coming from. UWB, by essence of the technology, eliminates all reflections and doesn't use it in calculations. The other thing is RF heavy environments can kind of get lost in the noise. UWB communicates over a very wide band, and it's very easy to differentiate from the noise because of that. And what makes us special in the UWB space. So there are other competitors, of course, but WISER does one thing that's our coup de grace very, very, very well, and that is we eliminate a lot of the cost and time intensivity of setup. So I was able to put this up in about 20 minutes this morning. Setup is generally very, very expensive for UWB because you have to calculate everything down to the nanometer to make sure that the antennas are fixed in one place, and that's what the calculations are based off of. We do auto calibration. So our algorithms are sophisticated enough to be able to put up a mesh like this quickly. We have an iterative process that measures the antennas from where they are in space, and they snap to either on a grid that we set up in the system or on a floor plan that the end user provides. So that means we can set up large facilities very, very quickly. I could probably do the rest of this building this afternoon if I had the antennas. So just a little bit about our business model, and thanks for bearing with me through the technical jargon there. We have hardware that we contract, manufacture, and have patented. So what you're looking at now is our antenna, at least in the form factors. These are our standard form factors, but a lot of folks will use other ones. But this antenna is what goes on the wall, creates the mesh grid, and the tags, which hopefully you've had a chance to see, are the picture in the middle there. And then the software, which you saw running in the beginning, we have a software as a service model for. So as you know, what actually runs the hardware is the software. You pay for that on an annual basis to be able to use the system. And so that's where the vast majority of our improvements from an IP and technical standpoint are coming in as well. So how are we doing so far with this model? We've had a viable product for about 2 years. First year, 2018, we sold about $700,000. All organically, and then in 2019 we are on target for 1.5 million. So we're happy with that. We'd like to see more growth soon. And we're able to do that because we have excellent customers with great needs that we handle well. So some of the markets that we serve right now are aviation manufacturing. Also, we have a logistics company that's growing with us pretty fast. We work with one of the largest retailers in the world. Automotive manufacturing, which I alluded to earlier, and then there's aviation maintenance and repair, so aerospace in general has been huge for us. And then we also work a lot with yard management. So over these next couple slides, what I'm going to do is just talk a bit about some of the pilots we have in place and how we expect them to grow in the next year or two. So for aviation maintenance and repair, this is a very specialized industry. It's one of the places we got started. For the full facility rollout from the pilot we have right now would be about 1.2 million. Full company rollout would be 9 million, and we estimate the U.S. total addressable market for this very specific niche at about 150 million. So automotive manufacturing, that facility, if they were to do the whole thing, would be about 19 million. Company rollout, 114 million, with a total addressable market in the United States of 800. And logistics, so this is huge for us. This is a huge growth place for us right now as well. That facility would be 4.2. The company, 640, but the total addressable market here would be around 25 billion as estimated. So with those pilots coming up, we do expect 2020 to be a much bigger year for us. We conservative, 10 million with other opportunities that I haven't talked about here. We believe that's a goal we can hit. I want to talk a little bit also about our roadmap. So we generally make most of our engineering decisions based on advanced idea of the marketplace. I personally do a lot of work with our customers, with potential customers to find out what they need to scale this into their own environment. We get a lot of external interest from long-term care and healthcare. So this is, when mom and dad get old, they need special care. You might put them in a long-term care facility, skilled nursing, assisted living, something like that. And these places are generally great, and they sell themselves as being able to provide better care than you could provide at home. So one of the things that they're very interested in is being able to track nurses to make sure that they're going on their rounds, doing the correct things, doing right by mom and dad, making sure they're cared for, and of course also to prevent elopement. So one of the things they need to be able to scale this is a button on our tags, a programmable button, so that should be done by the end of Q4 this year. Also, oil and gas is huge for us. Chevron's a venture partner. They want to put us in refineries, various things like that. They need it to be rated intrinsically safe. So that's also coming by the end of this year. Also, Canadian certification should be done, so we'll be moving into more international markets. By 2020, we're working on Z-axis. So what I just showed on the screen was just X and Y. It's very accurate. It's accurate down to a foot generally, even in tough environments. In this room, probably several centimeters, but I would not call this a terribly tough environment. Z-axis is there. It is, some of our customers are already testing it. We would call it probably in beta right now, as in we're not selling it. But by 2020, we expect to get that granularity down to shelf level. So you can track, maybe bins on shelves with the difference of 6 inches. And then we have a web app. So I was actually just testing this the other day. Our web app is going to be something that you can easily just pull up on your smartphone. Hey, where's my tool? Where's Jim? Where's my manager? Is my manager far enough away that I can go take a break or something? You can pull it up right on your phone here and take a look. And then European certification by the end of 2020 as well. So going forward, we do expect a lot of our growth to just be completely sales-based. It's how it's been going so far. We expect those enterprise rollouts to keep coming, and we are working actively to secure military and government contracts. So we're able to do this because we have a really great team. And I want to talk about 2 people in particular here. The first is our CEO, Dr. Rideout. Dr. Rideout comes to us with tons of entrepreneurial and management experience. She's held a ton of different jobs in government, in the private sector. She started many companies. She brings great leadership from a variety of backgrounds, so we're very lucky to have her. And then Dr. Holler. He was a electrical engineering graduate from MIT. And then he got his PhD in mechanical engineering at UC Berkeley. And he's the kind of guy that you throw a problem at, something people have been trying to solve, and he's like, well, I don't know, let's just try this. And it ends up being world class. So we're really lucky to have him as well. He's the genius behind a lot of our software. And of course, NASA. So we are super excited to be here. We're huge space nerds. We thought a lot about various ways you can use tracking, and of course, there's potential in the International Space Station to track payloads, track tools as when they go up and they're there, to make sure that counts are correct. You can do inventory that way. Then, of course, perhaps an alien planet like Mars, set up a very quick mesh like I did in a couple minutes and begins tracking there. I will say, though, for Mars, we do require a site survey for all the sites that we put up. So it might be good and proactive if NASA goes ahead and puts us into some sort of astronaut training program right now. It's probably be best for everybody. We, of course, do recognize that the most realistic application for tracking right now is right here on terra firma. So I'm very interested in learning more about what needs to be tracked between sites, between labs, so on and so forth. So I hope in the sessions after the presentations today I can learn more about that from you guys. So just wanted to take another moment to say huge thank you to the NASA iTech team. You guys have been instrumental in helping me kind of tell the WISER story, and you've been very supportive. I just want to say thank you very much. And without further ado, are there any questions?
Thank you. We now have about 15 minutes for questions from the judges.
So, right over here.
This is going to be fun.
Oh, thanks. So I've done a lot in the construction industry, but almost anything that involves moving big stuff around, including space, we have, advanced project management systems now and budgeting systems because time and materials are so important. Are you planning to integrate with these other systems and give them their data? And have you done this already, or what's the business plan?
That is absolutely part of our business plan, is to go through partners that do things like that. We provide the raw data. We have a REST API they could pull from. They incorporate that into their system, and they make the decisions just through their platform. They dashboard it through their platform. That's what we're currently doing with the retailer that I mentioned.
Okay. Thank you.
Mm-hmm.
So this is very exciting and looks very practical from many levels. what are you doing to prevent one of your competitors or another fast follower from leapfrogging ahead of you in the marketplace?
Sure, that's a great question. We do have patents. We also have trade secrets that we protect with our lives. But really, that's our strategy is to be constantly innovative so that, as we move forward, as we do anything new, it becomes patented, it becomes standard. I really hope that answers your question. There's some things that I don't quite want to get into that I can get into.
So let me talk
end.
cost for this. So what is your current unit cost and what is the volume cost? I mean, because I could see in order to really use this at NASA, we would have to tag hundreds or thousands of items at certain places. We need
Sure.
to track those things. We need to have real close inventory of the tags themselves and reuse and stuff like that. What is your bigger picture of the cost and how an organization would use this to make this as part of their infrastructure?
Sure. So right now, the highest cost driver, as you might have already surmised, is the tags. In bulk, they get down to about $30, so they're between $30 and $70. As our manufacturing increases, as you get bigger contracts, we already know that's going to go down substantially, up to 50%. There's ideas of making an even less expensive tag as well to do very simple tracking. But as of right now, the way we're handling it with folks with tons of needs who want to track on like the tool level, the individual, this is classically a high value asset, or tracking solution. But if they want to track on the tool level, we either have partners that can do that or we track pallet level. So that's kind of a very broad answer, but hopefully I can ask you some more specific questions after the presentation.
Actually, you answered part of my question. I wanted to know how small a parts you could track. But what happens if the parts you want to track is in a drawer?
Sure. As long as it's not a metal drawer, you should be fine. If it is a metal drawer, then you're going to see on the map the last ping location. So you can it's still going to get you to the drawer, basically. But you're correct to assume that once it's in the metal drawer, it's going to stop transmitting. But its dot will remain on the map the last time you saw it.
You said the largest. You gave a dimension for the network. What was the largest you could do that you?
Well, the largest we've done so far is about 300 antennas in a 400,000 square foot facility with multiple other facilities in separate meshes around it. So far as a contiguous mesh, we've tested the calibration, everything up to 1 million square feet, iteratively through the software. And there's a ton of different ways to get around that problem. We expect it to be scalable. The engineers gave me some inordinately high number yesterday that I don't think I want to share right now. But we expect it to be scalable either by multiple instances and up to several thousand antennas before you start to need to break up the software into separate portions.
Maybe slightly different take on Peter's question, but this also seems like a fairly crowded space. There's a lot of solutions out there for asset tracking. You kind of put out the competitive landscape of the technologies and why this type of technology is superior. What's your differentiator within the class of that technology? Like, is there IP protection? Is there other reasons why your solution is going to be differentiated or better than other ones in the same
It's definitely
class?
IP protection, and a lot of it does stem around the way the hardware interacts with the software. So our main differentiator from a very broad standpoint, I would personally say, is the ease of setup. A lot of the setups for UWB, which is considered the gold standard in RTLS right now, a lot of their setup costs will be in excess of the entire cost of our system.
And that's the part that you have patented that you don't think they can work around?
That
or
is certainly a
reproduce?
part that we have patents on, yes, multiple patents.
Okay.
Can you talk a little bit about your investors and how much they've been helping you and
Sure.
where they come in?
So we have some strategic investors, and a lot of it so far has been angel investors or family and friend rounds, things like that. Chevron's been a great help getting us into other markets, but the vast majority of growth that we've seen so far has been just organic through sales.
Elliot, how would you approach, or maybe have already approached, someone like Amazon?
Yeah, I would love to work with Amazon. That was something that actually was one of my first thoughts when I came on board at WISER. For Amazon, it's hard to tell. Again, I would need to kind of diagnose some of the issues they have. I can't really make a distinction with assuming some of the issues they might be having. Obviously, I'd love to track packages, but in that case, we would need to get our tag cost way down. So that's something that's probably more of a future conversation. Unless you had a specific use case at Amazon that you were thinking of.
No, they're putting in a new million square foot center in Edmonton, and they're relatively new to the business as well, so it'll be an interesting challenge.
And wouldn't it be great if they could construct the building with our hardware in it already? So.
Yeah.
Should work with Prologis Ventures then. They own a lot of the major shipping hubs.
Okay.
Which goes to my next question. So even if you just took real estate, construction, and logistics, that's over 25% of GDP. I've even gotten into medical care. You just pitched a product that could be applicable to 50% plus of our economy. And they all have different problems. Healthcare has privacy, construction has privacy, compliance, all sorts of things. Logistics is all over the world. You have issues with power, you have, you can be on a ship for months with a product, with a tracker in there. How's that data going to be stored? Obviously, people want shock. I could elaborate, but what I want to know is if you could pick any specific industry and customer that you were confident could bring this company to be a massive company, which there's like 50 answers for, what would you go with?
Sure. Sure. So we are trying really hard to be industry agnostic for that reason. Not that we don't want to specialize. We want to specialize in this product and what we do. Obviously, we make some small changes with the programmable button. Those are very small. If we had to pick a single industry so far as who's been very good to us so far, it has been aviation and aerospace, and specifically in manufacturing. It seems like manufacturing, with the ROI example I gave at the beginning of the presentation, they have a huge reason. They've already looked into this, tried to buy it, and it hasn't worked. So to have us come on site and show has been great for us, great for them, and it seems that that's where probably our biggest growth is. So from a strategic standpoint, I would want to say that. Just from where I'm at today, maybe NASA would be great. Did I answer your question?
Yeah.
Okay. I think aviation and aerospace so far would be my best answer.
And is
to
that because they love you or because you think that your technology is best in that sector?
It's a good question. I think it's because the technology is best. And I think that's why they love us.
And why is that?
Because of the ROI. Because generally, the plants I've been in, they have huge assembly lines, much like the one I described in automotive, where if things get shut down, they're losing potentially millions of dollars an hour. And they understand that ROI, and we're able to directly help them with that.
Thank you.
Thank you.
Yeah, recently there's been a lot of press you've seen about the pickers in Amazon warehouses. And I was wondering if, not just in terms of tracking a picker for Amazon, but the fact is they would obviously use that to be able to increase the efficiency of a picker because he's going here, he's going there, and it's like you could just look at the map and say, why are we picking like this? Why is this guy having to walk 17 miles a day? Is that valid?
Absolutely valid. A lot of times the initial use, we sell small kits. It's basically 5 antennas. Those can be customized. And a lot of times what people are doing with those kits is an initial proof of concept is replacing like the GoPro method or like the kind of cataloging method of tracking people and seeing where they go to talk about employee efficiency. They just put the floor plan on them, put the tags on them, watch where they go, and then someone who does data analytics or a program that does data analytics makes decisions on efficiency just from looking at the WISER chart. So that's a very classic entry into using our product.
The question I had is the tracker passive or is it active?
The actual tag? So the tag, it's actually a more complex question. We have various firmwares. So we have a tag that is passive, just sends data to the readers. We also have a tag that can receive data and make some small calculations as well. We call those hybrid tags. That's what I passed around today. It's just a firmware change. With either version, though, so long as the tag remains as is, and this is, I guess, not directly answering your question, but might be answering another question for some other folks. The battery is moving in constant motion for 8 hours a day, roughly. So an employee badge, which is generally the most active tags that we put on, will last about 2 years just on a single coin cell battery. So obviously it goes up from there. If you're tracking a pallet and it sits in the warehouse most of the time, the lifespan of that CR2032, the shelf life, is going to run out before the battery does.
So I think that's a big weakness, is the requirement for a battery, and RFID has you beat there. Is
Correct.
there anything to try to merge those technologies so that, or have another way to generate the power you need for whatever you need that power for?
We've looked into energy harvesting. We've looked into a couple various things. I think we're pretty far away right now from solving that problem. Right now, it seems that the market just wanted a battery that was going to last more than 24 hours that you had to recharge afterwards, like a lot of active tags. So we've solved that. That is certainly something that we're willing on taking on, and my CTO is aware of that, thinking about it, but I don't have a hard, firm answer on how we're going to solve that just yet, so sorry about that.
I
Good
think
question.
battery life is going to be an inhibitor for you. If you have short-term use, that's fine, but most of our stuff that we'll be tracking will be much longer term than a few months.
Sure, and it would be, is that here on Earth, or is that potentially going out into space?
Either.
Sure, so is potentially changing a battery every 2 to 5 years cost or labor intensive for you? I guess depending on the tags, it would be, right?
I prefer not to do it at all.
Sure, I completely understand that. How could I possibly argue with not doing it at all?
Who has power management issues, right?
Right, there you go, plugging in the phone right now. Okay, thanks for the question, it's good.
Also related to battery life, an interesting topic in asset management is if you want to address chain of custody or not, which, for if you have a vaccine, for example, and it's made in a factory, people have to sign it the entire way over so that the person getting the drugs knows it was really made. This is important when it comes to large pieces of equipment because you're talking about, was the object actually where I said it was, or did somebody spoof it, right? Are you planning to get into that space of actually saying that your data is proving reality? Or are you planning to just stay in the kind of data-heavy, not always perfectly accurate business, given that you're in the business of measuring physical devices and where they are and what they're doing?
I'm going to be completely honest with you and tell you that I personally have not thought about that. But if you're going to be at the impact tables later, I can call my CTO and try to get a better answer for you for that question.
Thank you.
Yes. Thank you.
If you were here yesterday, I asked a number of questions regarding the environmental conditions that we often deal with in space.
Yes.
Have you thought about how your technology will respond to those kinds of extremes of temperature, radiation, et cetera?
Yeah, so we've thought about it in regards to space, but have done no practical testing on it. We'd love a need to do practical testing on it. We have not stress tested the tags of the antennas, but we know that they work. And again, off the top of my head, I don't want to tell you the wrong range, so I'll look that up directly after this presentation and get back to you with that information.
It's especially true, too. It's a common issue we have with batteries in general, and whether your batteries could hold up to that kind of thing.
Sure. I think that's valid. Thank you. Anything else?
Thank you, Elliot.
Thank you.